Hey, welcome back to Global Environment. We're talking about global climate change, global warming, and in this segment we want to talk a little bit more about the implications, long-term implications of global warming. So let's look at this slide that we've seen earlier in the course. And again, this slide shows the strong correlation between basically our economy and mainly our fossil fuel use. And you can see how well these go up and down together, a strong correlation. Our wealth is derived from fossil fuels mainly. And if we want to keep the gravy train going, we're going to probably have to burn more fossil fuels. So what does that mean for the atmosphere? Okay, and again, this demonstrates it even more clearly. This graph, kind of interesting. What does it show? It shows basically the wealth per person down here and the amount of CO2 we release. And you can see the richer countries release more CO2. That's been the way things have run for a long time. So what's going to happen if we can't do this? What are the options really? Okay, this is a shot Charlie Hall took in China. And all over China, you can see smokestacks here in the distance. Carbon is being emitted through smokestacks. And they're sitting on lots of coal. Lots of coal. Their economy's flying. They're going to use more and more of it. And it's very low-quality coal that emits a lot of CO2. So we have to watch out for this. I mean, it's a side effect of growth. Now this graph shows global fossil fuel CO2 emissions over time. And again, this is not a big surprise, but because of growing affluence, growing population, we can see almost exponential growth in fossil fuel use. Now, the next graph puts it in a little more perspective. And what you see is the data, basically, I just showed you down here. That's the CO2 we've used. Now, the curve, the whole curve here, is basically all the CO2 we could use potentially if we burned all the coal, oil, and natural gas. So you can see how much CO2 could be emitted. Now, if we go to the next slide, we're going to see this curve again, but it's down here. That's that curve on the last slide. It looked really big on the last slide. That was all the CO2 we could emit. Now, what do we have? This shows all the CO2 that could accumulate in the atmosphere. Again, remember the residence time is very long, so once it gets up there, it stays there a long time. And if we look back at the graph, there's two estimations of how much will be taken up by the ocean. But again, if we look at total parts per million in the atmosphere of CO2, this is a huge increase. Now compare the last slide with this slide, because this makes the situation even more frightening. Remember this one, this compared temperature with CO2 in the atmosphere. Now, the last slide showed us all the CO2 that could end up in the atmosphere right here. You can see, again, this graph breaks over here. It breaks. This is a huge increase in the amount of CO2 in the atmosphere. Now, if temperature is following CO2, where could we end up? I mean, 12 degrees difference? I mean, that's huge. I mean, 3 degrees would be bad enough when it comes to ecosystems. That's what ecologists tell us. But 12 degrees, we're talking about a whole new world. The last time the atmosphere was 12 degrees hotter, it was a Carboniferous, and the world was covered with marshes and swamps. All right, so something we should really consider. It doesn't mean 12 degrees is going to happen, but if there's a chance of it, how does that impact policy? So we're going to stop right there, but let's think about global climate change in the context of the course. I mean, we saw how our economy was so tied to fossil fuels, which means more CO2 emissions. And we also had sections that looked at alternative energies and nuclear energies. How do these play into this? Are these a solution, a potential solution? How can we integrate these technologies? So keep that in mind as we go through the course. And I'll see you next time on Full Board.